So today is the first lesson on geometry. Okay. We are going to talk about angles. Okay. Geometry. It's called pre-algebra, and actually it's contained all kind of mathematics in this book. So more precisely, it shouldn't be called pre-algebra, called pre-mathematics or elementary mathematics. Okay. Because otherwise it's kind of misleading, pre-algebra. Algebra, in my opinion, is about functions, polynomials, all kind of, related to algebraic expressions, okay, word problems, okay. Then mathematics also included number theory, probability, and the geometry. Okay, geometry begins with angles. Then area, then Pythagorean series, and application Pythagorean theory, then 3D geometry, and so on. Okay, so the more detailed classification, yeah. Okay, so if more advanced mathematics you study, and you find out there are even more subjects, topics in this area. Okay. All right. First of all, we should understand what is a point. A point in mathematics is a something which has a zero dimension, okay, and no size. You cannot tell how big of the point, okay, and otherwise it's not going to be called point in mathematics. Okay, it can zoom in and you can see, as it's so small, but I just point and the size is going to be zero. Okay, has no radius, and even when I drop it, of course I plot the point on the xy plane in the plane, but this has no size. Okay, now line segment consists of 2 points. Okay, we usually denote, a point usually denoted by P or some use letters. Okay, because if we have more than 2 points in the plane, you use you have to use the letters. Okay, point A, point B, point C or point P. We have to name it. Otherwise, how do you tell? Right? Now, if we have 2 points in a plane, then we are talking about flat geometry. Okay, so it's not curved space. Our space is flat. So then there is a concept line. So then the so-called line is the shortest path, okay, from between A and B, and it's a strict line. Okay, yeah. In more advanced geometry, you have to give a precise definition. What is a line? Okay, what is strict line? Because in our universe, the path for the light we call a strict line. Okay, but you know that according to Albert Einstein theory, the light can be bent, okay, can be curved, okay, around the bigger star. So what's the definition of strict line, right? So here we assume that everything's perfect, it's flat, Euclidean space, then strict lines it's easy to understand the concept. So a line segment between A and B is just one piece of line, and it's usually denoted by A and B. Okay, something like that. Okay, denoted by A and B. Okay, and you put a bar on top. That's the kind of line segment from between A and B. Okay, that now lines are a different concept. Lines, if the lines, you have to extend it in 2 directions. Okay. So usually we put the arrows symbols on both sides, and you still use A and B. Okay, so that notation means a line passing through A and B. Okay, a line passing through A and B. Okay, is denoted by above notation. Okay, and this is a line segment between A and B. Okay, so you have 2 endpoints here. So there's a difference: line segment and the line. line is it's going beyond, you could extend, to both direction. Okay, so that's the concept, a line and the rays. What is a ray? Rays means that you have a point A and a point B, and it's only extending in one direction. So this is called the origin of the ray. Okay, so you can denote by this notation, just one direction arrow. Okay, so this is the ray from A and B. Okay, so a ray is basically just a half line. It's one extended to infinity in one direction. Okay, and the starting point is called the origin. Okay, and if it starts from A and passes through B, okay, a lane, okay, starting from A, passing through B is denoted by this notation A, B, okay, in the book, or in most of the books. All right, now using using the rays, we can talk about the angle. So here's the definition of the angle. Okay, angle, when the two rays share an origin, they form an angle. Okay, the common origin is called the vertex, and the rays are called the side of it. Okay, so here's you have two lanes. Okay, if you have two lanes, one, okay, another lane, two. Okay, so I call it O. Okay, if this is point A, that's point B. So those two rays, they share an origin. Okay, and that's called the vertex, and this is called the angle. So the angle is denoted also. The angle formed by two rays, OA and OB. Okay, we're going to denote it by, usually by like that, AOB. Okay, AOB start from A and going that. Okay, now so this is the angle, but then there is actually the issue here. Which one you're talking about? The bigger one or the small one? Okay, so this is the angle. How about the other side? Right? So it's not very precise. You have to talk about the in more advanced mathematics, you have to say which side is called initial side, which side is terminal side, and you rotate counterclockwise. Okay, you rotate counterclockwise. So OB is considered the initial side, OA is the terminal side. Then the angle actually has an orientation. Okay, so you have to from B to A. Okay, so right now we just say angle. Yeah, we simply that. Yeah, we assume that the angle is always we're talking about the smaller one, formed by two rays. Okay, so actually on the plane you can at least you have two angles you can talk about, right? So sometimes like that, then you which one, right? This is A, that's a B, that's O, and they form a straight line, right? And then you say the angle AOB. What does it mean? Which angle you're talking about? So the one on the top or the one at the bottom, both, right? So that is a little bit confused. Right now, so then we come to the measurement. How do we measure the angle? How do we measure the angle? You have to complete a circle. So this is suppose A and the B are both at the same point. So then the angle, the two ways to measure it, okay? This is called complete circle. So the angle AOB in this case, either it's called degree there, or depends on how do you measure it. And the other side is 360. So complete this whole circle, we assign a value to measure the size of the angle. The complete circle we call 360 degree. Okay, we say the complete circle has a 360 degree. Okay, using that, this is definition. That's you can say, you can define the complete new measurement system. You can say the complete circle is going to be 10 degree or 20 degree, or you don't use the name of degree. You can use, say, 10 whatever call it, right? Yeah. So then you can use that one new measure system to measure all the sides or angle. Okay, you can use a number. Okay, you can use a number, and later on you will see that if we so think about that, right? So you divide the whole circle into 4 equal parts. In the 4 equal parts, and then each of this angle, right? It's going to be 90 degree, because 360 divided by 4 is going to be 90. So it's 90 and then 90 and then 90. Okay, so all those angles are 90 degrees. If we divide them into 4 equal angles, this complete circle. So 90 plus 90 plus 90 plus 90 is 360. Okay, now indeed, there is someone else. They introduced another measurement system. Okay, they measure this angle. Okay, so let's see. Here's angle. Okay, this O and A and B. That's a strict line. This will be half of the 360 degrees. So 360 divided by 2, it's 180 degree. Okay, so 180 degree, right? It's 180 degree. So this angle, the flat angle, doesn't matter which side you're going to measure. Okay, so we usually do a counterclockwise. Okay, going counterclockwise. Okay, I usually walk, always means counterclockwise. Okay. But you still have to decide which side is the initial side, and that's why I want to mention a little bit more than what it says in the book. Okay, so if OA is the initial side, OB is the terminal side, the angle will be 180 degree in this case, friend. Okay, all right. So I have to I want to tell you that there are another measurement system, and this angle we use a number instead of degree. This angle, as how big of the angle, we say this angle is pi. Okay, pi is a number which tells you how big of the angle. Okay, so then 90 degree will be half of the pi. Okay, 60 degree will be pi over 3, and so on. Okay, so there's 2 different measurement systems, at least existing in the world. Just like we in the United States, we use measure the length, not the angle. Okay, we use inches, right? Feet, right? Like 3, how tall you are and a driver's license, you say 5 feet 3 inches. But in China, we never use the inches. No, they use the meters. They have to say 165 centimeters high. So you have to do the converting. Otherwise, to Chinese people, sometimes they come to this country, they have no sense about how tall this guy is. 5 feet, 5 inches. How tall? They have no idea. They have to look at the conversion table to translate. When they're talking about this guy, 175 centimeters high, they can imagine how high is this person. Okay, so 2 measurements, and for the angle, we do also have 2 measurements. Okay, measurements. Right now, we just focus on the degree measurement. Okay, we define the whole circle 360 degree. Okay, then and this angle we simply call the right angle. Right angle means that it's 90 degree. Okay, because you divide the whole circle equally into 4 parts. And then you get 90 degree each. So this is the right angle. Okay, why call it right angle? Because it shows up everywhere. If we study, if we have a rectangle, right, and this is going to be 90 degree and then 90 degree, right, 90 degree. This angle is also 90 degree. So rectangle, all the angles are 90 degree. Okay. So we're going to study rectangle a little bit later. Okay. All right. Now we're going to think about the clock. Okay. We're going to look at the clock. The clock Okay, let me draw the clock. Okay, 3 o'clock a.m. How do you measure? 3. Okay, 3, right? This is the hour hand, and this will be the minute hand. Okay, right? Remember, this is a 3, right? Here's a this is a 1. That's 2, 4, 5, 6, right? It's 12. So 3 o'clock is exactly right, and clearly it's 90 degrees. So you see here to have the special measurement, the smaller angle between the hour hand and minute hand, because there's really 2 angles you can talk about, right? So the smaller one, okay, the smaller one, and it's clearly it's a 90 degrees. So answer is 90 degrees. Okay. Now think about the angle, right? That's one section. Let's see, 1, 2, 3. So one sector here between 2 integers, that is going to be 90 degree divided 3, so 30 degrees each, right? 30 degrees each. All right. Now imagine the minute hand rotate a little bit. Okay. If the minute hand rotate a little bit, then the hour hand also rotate a little bit, even smaller. So this angle, okay, then you get then it's harder to measure this angle, right? So we're going to look at such problem. You know, we already studied the rate and the proportion. So we probably use that to find to solve a problem. Okay. Okay. So imagine it's if it's like 320, okay, or 340 or 350. So what is the angle between them? Okay, what is the angle between them? Okay. The difference of the angle. All right, so let's see. Think about this problem at 330. What is the measure of the small angle between this hour hand in the hand? Okay, then we try to do a little bit more generally. Okay, first of all, you draw the picture. Okay, you draw the picture. Okay. Okay. This is more general, right? Okay, 3 o'clock. So here's a 3 and the 1, and 330 means, okay, it's a half of that. It's a 4 and the 5 and the 6, right? So the minute hand will be here. So our hand is not on point 3. It will be between 3 and 4. Okay. Right? So it's this is our hand, but since it's 330, I think it is easy to figure out the angle. Okay, either way, you know, this angle, okay, is going to be half of the angle between 3 and 4. So it's a 30 degree divided by 2, it's a 15 degree. Okay. Right? Yeah. So from this picture, I'm trying to use this take a difference. Okay. If this angle, I call it alpha, and that angle I call it beta, and the difference. Okay, that's I use our notation, simple notation. Usually for the angles, we use Greek letters. Okay, so let's see, alpha is going to be 180 degree, right? Yeah, and the beta is going to be 90 degree plus 15 degrees. So references initial side actually it's this rotated clockwise. The initial side is a vertical line pointed to the north. Okay, so it's going to be 105 degree, and then you will see the difference alpha minus beta is a positive difference, and that is going to be right 180 minus 105 degree, Okay, so that is going to be just 75 degrees. Okay, 75 degrees. Right, so that is angle. It's a between it's a 75 degree. Or you can also just take a difference, 90 degree minus 15 degree. That is yeah. If you just focus on that small bit, but I think we should use a references axis called references axis. Okay, then that's our starting point. Then you just take a difference of each angle between the hand or minute hand or hour hand and the references axis. Okay, then you take a difference, then it's much easier to handle. Okay, right. All right. Maybe we can try a more challenging problem. 6:24 a.m. Okay, what is the measure of the smaller angle between the hour and the minute hand? Okay, number one, you know, step one, you measure. Yeah, you draw the picture. Okay, draw the picture. Okay, 6:24. 24 is somehow like that. That's that's 6, right? And the 5 and the 4 and the 15, right? It's 12. So let's draw the minute hand. The minute hand is going to be, right, 15, 20, 25, 24 is somewhere here, right? This is a minute hand. So the hour hand is not 0.6. It's a little bit, this is a 7, right? It's somehow close to the middle. Okay. Okay. Let's try to figure out the angle. I hope some of you can do that. Yeah, I let you to try for 1 minute. Okay, then I'm going to show you. My idea is I still use the references thing. Okay, I call it this one maybe alpha. That one's beta. I'm going to find out alpha minus beta. Okay, you know, it's a difference. So that gives the angle, right? Right. Then use a proportion. Okay. Can you find the beta and alpha separately? Then you take a difference. Alpha is slightly larger than 180 degrees. So anyone has answer now? Can you figure the alpha and the beta? Okay. So first of all, let's figure out the beta. Okay. So think about that. If a beta, it's a 24, right? Total is a 60. Total is a 60 minutes, right? 60 minutes. 24 is almost, close to half. So that in about total, degree six. If it's 60 minutes, then it'll be 360 degrees. So we don't know the beta. Okay, so that's the ratio. Okay, we call it ratio. That keep the ratio. Right? When you beta, when beta, beta is the angle, right? So 24, clear, right? 24 over 60. Yeah, this is about the minutes, the ratio, right? 24 of 60 is going to be should be equal to beta over 360 degrees. Okay, if the time is almost 60 minutes, then beta should be almost 360 degrees. So let's find the beta. Okay, 360 degree and divide by 6 times 24. Okay, so so what you get here is 6, right? 60 degree times 24. Okay, so this will be the if you do the you can multiply this out if you want, right? So 6 times 24, it's actually 144 degrees. So you can get the exact value of 144. Okay, now the difficult part is about alpha. Well, it's not that bad. Okay, so alpha should be consists of these two parts. I'm going to call this one theta, right? So when the angle beta increased from 1 minute to 60 minutes, theta increased from 0 to 30 degrees. So 24 over 60 should be equal to theta over 30 degrees, right? Right? Think about it, right? If 24 changes, change it to 30, change to 60 almost, right? Then theta changes from from 15 degree to 60. So this 15 degree to 30 degree, yeah. So we will get 30 degree 60 times 24. Okay. So so it's going to be 12 degree. Clear? Yeah, if we multiply this up. So it's 12 degree. Now, if this 12 degree, alpha is going to be actually 6 o'clock, right? It's a 180 degree plus 12 degree. It's going to be 192 degree. So you get those two exactly. So then the difference, alpha minus beta, 192 degree minus 144 degree. Okay, then you do the calculation and you get the exact, you get the answer, 144. So it's a 48 degree. Okay, this is the most challenging problem. Okay, my suggestion to you is always to find use the references axis from north. Okay, then you measure the degree, measure the angle between the axis, reference axis, and the hour hand or the minute hand. Okay, right. Use a proportion. Okay, use a proportion. Okay, then you should be able to get each of the angle. Then you take. Yeah. Someday later, we have to solve the inverse problem. Like, can you find the time so that the hour hand and the minute hand form an angle of a degree 20, 20 degree, for example? That's more challenging. Okay. So let's stop and work on some other problems. Two angles that add to 180 degree called a supplementary angle. It's hard. Yeah, sometimes it's hard to memorize. What's the difference between supplementary and complementary? Okay, so if you have angles, this is alpha, this is a beta. We don't want to use the letters. Okay, so this is a supplementary. Okay, alpha plus beta equals 180 degree. Now, if this is right angle, 90 degree, right? and then here's alpha, there's a beta. So this two angle is called complementary to each other. Okay, alpha plus beta is going to be 90 degrees. Okay. Right. So just the terminology, sometimes you will switch there and confuse the complementary thought is the sum of the two angles going to be 180 degrees. So actually supplementary to each other, then the sum of those two angles give me 180 degrees. Okay, so that's just a just definition. Okay, now let's take a look at the following example. Okay, so it says that X and the line YZ intersect the point P. And we want to show that the angle WPZ, this angle, okay? I call alpha, okay? Then the other one, YPX, we want to show that alpha equals beta. And why? That's true. Well, that's obvious, right? Those two angles opposite to each other. So how do you prove it, right? Show that alpha equals beta. Okay. Now I'm going to also denote this by gamma, okay? So to prove, prove, you have to write the word proof, okay? Right? Now I want to give an explanation why alpha is going to be equal to beta. Okay. So the argument is as follows. Alpha and gamma, they are supplementary. So 180 degrees, right? Do you agree? Yeah. And on the other hand, gamma and the beta is also supplementary to each other. All right, based on these two equations, then you take the difference of equation 1 minus equation 2. So gamma will be gone. So it's on the left-hand side of alpha minus beta. On the right-hand side, it's going to be 0 degree. Okay, because 100 degree minus 100 degrees is going to be 0. So that's why alpha must be equal to beta. So we conclude that alpha equals beta. Okay, so in mathematics, in geometry, sometimes you have to give a proof. Okay, you cannot say it's obvious, I look at, okay? That's not it's obvious, but you have to give a proof, okay? Yeah, and we know that if we have a line, right? So this is alpha, right? And this is a gamma, right? So this is a strict line. So alpha plus gamma equal 180 degrees because that's supplementary to each other. Okay. That's a property we use. All right. All right. Congruent angles are angles that have the same measures. Okay. When we say two angles congruent, right? And then maybe in different location, here's alpha, here's beta. So those two angles, right? If alpha equals beta, and they're congruent. Okay, maybe they're different locations in the plane. Okay. So, but they're congruent, we say they're just the same. Okay, that's another terminology. So two angles are equal, then we say they're congruent. All right, so now, let's take a look at this story problem, word problem. The measure of the one angle is formed by two intersection lines, okay? Is 5 times the measure of the another angle formed by formed by the lines. Okay. Find the measure of the angle formed by the lines. Oh my God, it's a typos. Okay, so let's draw the picture. Okay. We have two angles, two lines, right? That's one angle formed by two lines is 5 times another angle. Okay, right? 5 times is the measure of the another angle of the formed by these two lines, because there is only two type of angles here, right? The two types of angle here, we already know that those must be so opposite. The angles opposite side that must be equal, right? So we use that fact. There are only two types of angles here. So we know that given alpha equals 5 times beta, we want to find out alpha and the beta. Okay. So can you do this? Okay. All right. So, oh, yeah, great. I got one answers from some of you. Okay. So the key point here is alpha and beta are supplemented to each other, right? By definition, right? Supplemented to each other, because this is a, yeah, we already put it. So that you have to use another hidden equation. So 180 degree. Okay. Now that's a hidden equation, 180 degree. Then you have another one, alpha equals 5 beta. Okay. So therefore, then you can solve it, right? You can solve for alpha or solve for beta first. Let's solve for alpha first. So alpha, solve beta first. So it's 180 degree minus beta equals 5 beta, right? Right? So therefore, 180 degree equals 6 beta, and then beta equals 30 degree. Okay. So once you get that, then alpha equals 5 times 30 degree. It's 150 degree. So you have to solve a simple system linear equation, but there's a hidden equation you have to mention. Okay. You have to mention the hidden equation. You have to mention. Okay. Which is alpha plus beta, 180 degree. Okay. All right. So the next problem, let's draw the picture. The measure of the angle is 60 degree more than twice of the supplement angle. So we're talking about the angle here, supplement angle, okay? So this is alpha, that's a beta, right? Right? Okay. So we go back, let's go back, right? So this is a supplement angle, sorry, complement supplement, yeah, don't confuse. Supplement angle. Supplement angle is 180 degree. Okay. Yeah, supplement angle, yeah. 180 degree. So let me redraw the picture. That's easy to confuse. Yeah. So it's a very similar problem right now as above, right? So this is a picture. Yeah. This is alpha, this is beta. So these two angles are supplement each other, right? And how do you write down the given information and then try to find those two angles. Right. So supplemented to each other, that means the sum of those two angles is 180 degrees, right? Can you figure it out? Hey, thank you. So first of all, you write down the hidden equation, which is alpha plus beta is 180 degrees, right? The second equation says alpha is a 60 degree more than twice of the supplement angle. Okay, so you have two equations, and then from here, right, 60 degree more than, right? Twice the supplement angle. Its supplement angle is better, right? Then you can use the second equation put into the first equation. So 60 degrees, that's alpha, right? So this is alpha, okay? And they call 180 degree. So 3 beta equals 180 minus 60 degree, right? It's again 120 degree, right? Yeah, 110 degree divided by 3, right? Right? It's a 40 degree. Okay. So once you get 40 degrees, then you can get alpha. Alpha is going to be 60 degree plus 2 times 40 degree, 60 degree plus 80 degree, which is 140 degree. Okay. Or just take the difference, because they're supplemented to each other. Okay. So 40 and 140. Good. So Michael Lee, okay, give me different answers. So what, yeah, double check your work, and some things are, messed up, wrong, okay? So draw the picture always, then you label the angles, use the alpha, beta, gamma, and you can use ABC. But traditionally we use those letters, okay? Greek letters, alpha, beta, gamma. Okay, then you write down the equation, then yeah, and then also mention the hidden equation, then you solve the problem. Okay. Yeah. Alpha equals 60 plus 2b. Right. Okay. All right. So let's work out the similar problems. The measure of an angle is 12 degree less than 5 times its complementary angle. Find the measure of the angle. Now, complementary means the sum of two angles is 90 degrees. So you draw the picture. Okay. So this is a beta. This is alpha. I think the one of the angle much larger, because yeah, alpha should be larger, right? Yeah. So alpha should be equal to 5 beta minus 12 degrees. Please go ahead to solve this problem. And if you have answers, then post to me. Okay. Yeah. Okay. Easton Xiao has answered here. So let's see. Anyone else? Please hurry up. Don't be shy. I'm waiting for your answers. All right, we're running out of time, so I'm going to show it to you. Okay, so first of all, you write down the hidden equation, then you translate the sentence in the problem to another equation. So the angle, okay, let's call it alpha, okay, is going to be 5 times its complementary minus 12 degrees, okay? So you have two equations. You have two equations, right? 5 times, yeah, 12 degrees less than 5 times its complementary angle. So then use the second equation, plug into the first equation, 5 beta minus 12 degrees plus beta equals 90 degrees, right? This is alpha, right? So then you have a 6 beta, and then 90 degrees plus 12 degrees is going to be 102 degrees, okay? And from here, you can get a beta, right? You can get a beta. 102 divided by 6, it's a 17. Right? Once you get 17, then you can get alpha, right? Alpha is going to be supplement, 90 degrees minus beta, okay? Minus 17, right? So then 90 minus 17, so it's 73 degrees. So you get those two angles. Great. Okay. I'm happy you still. Now our next problem a little bit different. Okay, we know COB. Okay, so this angle and the B, where's the B? BOF. Okay, so COB, BOF. All right, is there any other conditions? Let me double check. All right, so this is from where? So we have additional assumption here. The 3 line segments intersect at the point O, and OD divide the COE into 3 equal parts. So these two angles are same, okay? And the ratio, yeah, they need the same. That's it. This is from math class, actually. Okay. So we have we know these two angles are same. Okay. And we also know that the COB, yes, COB is to BOF is going to be 72. Okay, so let's try to find out the angles COD. Okay, we're trying to find the angle alpha. Okay, find alpha basically. Okay. Yeah, I'm going to enlarge the angle, so it's too small. Okay, you can try to work on this right now. Okay, give you 1 minute to think about and can quickly grab. If you're able to figure it out, let me know. All right. All right, so let's draw the picture here. Okay, I think if we can find out, so this is a, yeah, I'm going to call this is a beta, okay? And I'll call this one gamma. Okay, right? So we are given the following information. Okay, beta to gamma equals 7 to 2. Okay, but we also know that beta plus gamma is 180 degrees. Okay, so we just needed to find out gamma. Okay, because alpha is going to be half of the gamma, right? So I just need to find the gamma. If when you set up this equation, then the rest of them simple. So if we are given the ratio, how can I find the gamma, right? Well, beta, you see, beta over gamma equals 7 over 2. So beta is going to be 7 over 2 gamma, right? So you plug it into the second equation. This will be 7 over 2 gamma plus gamma equals 180 degrees. So that equation is going to be 9 over 2 gamma equals 180 degrees. And from here, I got half of the gamma, okay, is going to be 20 degrees divided by 9. I think, yeah, some of you, yeah, it's 20 degrees. Okay, half of the gamma is 20 degrees. Okay, so that's all we, that is our answer. So alpha is going to be 20 degrees. Now you forgot Michael, you forgot divide by 2, okay? So alpha is 20 degrees. Okay, alpha is half of the gamma, okay? All right, so that is, yeah, you have to draw the picture, use, then you write on the given information about the angles, then you should be able to solve it, okay? Now this is a little bit more complicated. So we basically we rotate the right angles counterclockwise, okay, right? And we are told that angle AOB, this angle, to the angle AOD is 5 to 17, okay, right? AOD and AOB, okay? I'm trying to find out POC. So here's the idea, okay? Don't be confused. If this angle I call the alpha, right? Okay, this angle called alpha. Then that angle will be 90 degree minus alpha, right? That angle is also going to be alpha. Do you know why? Because you rotate the alpha, right? The right angle, rotate alpha counterclockwise. So the angle AOB is alpha. The angle AOD is going to be, right? It's going to be actually is going to be a 90 degree plus alpha. That's it. You know, once you express that in this form, B, right? Then you can use above equation, alpha over 90 degree times, all right? It's going to be 5 to 17, AOD, okay? So you can solve for alpha, okay? You multiply this out, 17 alpha equals 5, 90 degree plus alpha, and the 5 alpha, okay? So 17 alpha minus 5 alpha is 12 alpha, okay? So now, let's figure out what is alpha, okay? So 350 divided by 12, well, it will be a fraction. So am I right? And let me double check my work, okay? So you rotate alpha and 90 degree, right? And so total, yeah, let's see, AOD, this is going to be 90 degree plus alpha, and BOA, AOB is alpha, okay? So it's correct, okay? 9 times 50, no, 45, sorry, so that's my mistake. Okay, 45, okay? 5 times 9, 45. So now it's divisible, okay? 45 divided by 12. Yeah, it's almost divisible, right? So so alpha is going to be 45 degree, 450 degree divided by 2. Okay, divided by 2, it's going to be 70.5 degree. Okay, so the angle B, we want to find out BOC, right? BOC is complementary to alpha, so 90 degree minus alpha. So 90 degree minus 37.5 degree, and that is going to be 52.5 degree. Okay, so you have to be a little bit careful when you do the computation. Okay, okay, got it? Yeah. The last topic I want to take a few words talking about this. When we say two lines are parallel, means they do not meet. Okay, if we extend it to those, but how do you check whether two lines are parallel? Okay, if you look at this angle here is alpha and this is a beta, okay, so that means two lines parallel if only if alpha equals beta, okay, so the line AB is parallel to CD if and only if alpha equals beta. You can check that. Okay, right. That's because if they do not have the same angle, then eventually they are going to meet because they're going to form a triangle. Okay, if these two angles, one is larger than one small. Okay, if those two angles are not equal, okay, if they're not equal, doesn't matter which one is, then they intersect somewhere, okay, and then you can get a gamma, okay, you can even calculate the gamma. The gamma actually is going to be alpha minus beta, okay, yeah, the gamma you can figure out the angle gamma, yeah, so there's the angle otherwise, okay, if alpha is greater than, yeah, if alpha is greater than beta in that case, and they will intersect. They're not parallel, and you can even compute the gamma. Okay. Okay. We're going to study this later on about the angles in the polygon. Okay. And yeah, this is all I want to talk about. I don't have much time about the parallel lines, but you see that parallel lines, if the parallel lines, then those two angles are the same. And then, yeah, that's a very key important problem. Sometimes you're given problems, you're not told that alpha equals beta because you're told it's parallel, but you can use that property to calculate the measures of the as the angles in the picture. Okay, so I have to stop here, and I'm going to give an assignment. We're going to have 2 classes on angles. My second class on angle will be still slightly mention the parallelized. Then I will talk about angles in polygon. Okay, and this is a very important topic, angles in polygon, in the next class. Then we move on to study other topics. Okay, so yeah, see you next class.